Welcome to Book Screen Talk, and let's solve today's problem. Minimum number of arrows to burst balloons. There are some spherical balloons taped onto a flat wall that represent the xy plane. The balloons are represented in a 2D array points, where points of I, x of start and x of end, denotes a balloon whose horizontal diameter stretches between x of start and x of end. So basically, we are given an array of intervals which represents the diameter of the balloons, and you don't need to know the exact y coordinates of the balloons, so they may be scattered anywhere across the y-axis, but the x-axis ranges are given to us. Arrows can be shot up directly vertically in the positive y direction from different points along the x-axis. When is the balloon burst? It's burst when the x which you chose is greater than or equal to the start position of the interval and less than or equal to the end position. There's no limit to the number of arrows that can be shot, and a short arrow keeps traveling indefinitely, bursting any balloons in its path. Given the array points, return the minimum number of arrows that must be shot to burst all balloons. Now, when I first read this problem, I had a bit of trouble visualizing the whole balloons and the arrow situation. So I drew some sketches for you to understand better. Let's quickly jump into that. Right. So in the first example, we are given the points array. If you think about it, we need to sort the array first if we want to find out any common intersection or any common arrow that will pierce two balloons or three balloons at once, right? So once we have the array sorted according to the start of the interval, and upon sketching the diameters just for a little more visualization, we can observe that you can use any of these intervals from 2 to 5 to actually pierce these two balloons, correct? So you can send an arrow from 2, 3, 4, or 5 to pierce both these balloons. But if you use 6, you won't be able to pierce the first balloon. You'll be able to pierce only the second balloon, right? So this interval is what matters. 2 to 5 matters. The same thing with this. You can send a balloon from, you could send an arrow from 7 that will pierce this balloon and this balloon, but it won't pierce this balloon. But if you know both these balloons are being burst by one arrow here, so we know the intersection of this will be 10 and whichever is this. So I think it is 12, right? So yeah, that's 12. So 10 to 12 is the intersection which we need to worry about. Now in the third example which they give, after sorting and drawing it out, we get something like this. In this again, if you send an arrow at 1, you'll burst only one balloon. But if you send an arrow at 2, you burst 1 and 2. If you send an arrow at 3, you burst only one balloon. But if you send an arrow at 4, you burst this one and this one. So the minimum number of balloons you need is 2. The minimum number of arrows you need is 2, right? And what if there is no intersection between any of the intervals? Now they have handled that in the second example. So after sorting, it's the same array. So if you visualize it, you'll be able to see that you will need individual arrows to burst these bubbles. Why? Because there is absolutely no intersection between any of the intervals. Had there been an intersection, we could have used one arrow to pierce two balloons, but that's not the case here. That is why we will need 4 arrows. Now, how do you know you need 4 arrows? It's easy because there are 4 balloons, right? Without any interaction. So without any intersection. So if you think about it, you'll realize that no matter what your answer is or what the minimum number of arrows is, the maximum number of count of arrows is always going to be the length of your array, right? Because that's the number of balloons you have. If we start with the length of the array and decrement every time we find an intersection, won't it be the answer of the problem? Because after each intersection, we are sure that that intersection is going to have one arrow in common. So that is why it is wise to start with the output as the length of your nums array, as in your points array. How do you know that a sequence is intersecting? All you have to do is check. Suppose we're checking these two intervals, right? Suppose we're checking these two intervals. We have to check whether the start of the second interval is less than the end of the first interval. If that's the case, then yes, they are intersecting, right? And we don't have to worry about whether this start comes before this start. Why? Because we have already sorted the array, so we know that this start will always come after this start. So we don't have to worry about the starts, right? You just have to worry about whether this start is less than this start, because less than equal to in our case. If it is not less than equal to, then definitely be not less than equal to any further, um, intersections. If suppose we are comparing these two intervals, and we know that the start of this interval is not less than this interval. So we know for a fact, for sure, that the next interval in this series, that is this one, will never be an intersection with this, because the one before itself is not an intersection, correct? So once we see that, two intervals are not intersecting, we move on, and we don't check for each and every, like it's not a brute force method. Like you don't go and check your intervals with all of the remaining. If this and this does not intersect, that's for sure that these two won't intersect, and these two for sure won't intersect. So we don't have to worry about those. All right. So let's look at the code which I wrote before, and I'll get to the point why it failed few test cases, why it failed a few test cases, and when I saw Leetcode's code, it just dawned on me what I was doing wrong. So this was my code for this problem. What I did was I just sorted the array first, then initialized my count, which will be my output, the minimum number of arrows required to burst balloons, which is of course length of points. Then while I initialized my previous pointer to 0 and my next pointer to 1, right? While next is less than length of sorted points minus 1. So I just iterated, like I could have used a for loop. I don't know why I used a while loop. I don't know. In the moment I just used the while loop. Then just have a look at the code, and I'll just show you the output where it was failing in a bit. So the main point is you check if the start of the second interval is less than or equal to the end of the first interval. If so, then there is an overlap. So you append the first index of the next one, right? First index of the next interval and the minimum of these two numbers, right? Because if you look at the example, right, when you're considering this intersection, correct, you could have taken, the starting point is going to be 2 always, but what do you take, the 5 or this, right? So you have to take the minimum of these two, because that will be the intersection point. So that is why we wrote it like that in the code, right? And then you just append the subset, so that is next plus 1 and end of the list. And of course you decrement the counter, you decrement the counter, and if there is no overlap, previous becomes next and next is previous plus 1. Now this was returning a wrong output for this test case, right? Just have a look at it. And where I was failing to take into account the edge case was, there is an array which gets appended 3, 3. This is not supposed to be in the points array because this is balloon with a 0 diameter, right? So this is where my code was failing, and I had to look at Leetcode's code to understand this. This is the accepted code. All we do is we sort the array, then initialize the result, previous and next. These are the 2 pointers that we keep track of. We don't have to keep track of the subarray. We just have to keep track of the previous pointer and the next pointer. We are not bothered with what the subarray will look like or whatever. So you just have previous and next, right? For I, since previous is points of 0, we start our indexing from the first index, right? So next equals points of I, whichever index is in that loop, correct? If again the end of the next interval is less than equal to the previous of the previous interval, then we found an overlap. So result decrement 1. So what are we doing basically is merging the 2 intervals. That means the first of the interval, that is the start of the interval, will be next of 0. But the ending of the interval will be the minimum of those two. As in, what will be the end of the interval? It will be minimum of these two. So the intersection cannot end at 8, because we know that the minimum of these two is 5, right? So it has to end at 5, which is the minimum of the ends of these two, correct? And if there's no overlap, that means previous will be next. So 1, 2, and 3, 4 don't have an overlap. So for me, this is previous and this is next, right? So when you say previous becomes next, that means my previous is now here and next will be this one, right? Because, because that's how the looping works. And then you just return the result. That's it for today. Subscribe for more.